Good morning again, or good afternoon to everyone. You should be looking at an outline for the Feeder Takeoff webinar here we're going to do today. We call these pop-up webinars. The idea is that they're kind of a quick look at one part of the program, and we felt that feeders, along with the next one, which will be fixture takeoff, are really two of the most critical, time-consuming, as far as the cost of your estimate. So that's why we chose those two modules, those two parts of the program to focus in on. You don't have to make any notes here. We do have these webinars recorded. You're always free to go back and watch them again, but these are the topics we're going to cover here today. So we're going to start with a little bit of discussion on the default settings for the feeders. It actually isn't on the list here, but I'll take you to that first. So let me flip over to the EVM screen. In the default part of the takeoff program, you may not even know about this part of the program if you haven't visited here before. Under settings, there's default settings for takeoff, commercial. Each takeoff module has its own setup, so that when you open the feeder module versus the branch circuits versus the site, each of these screens has its own default setup. So where I'm pointing here under feeders is the settings you can customize preset for feeders. It's a global thing. So when you're in the job, you can still choose other types of conduit, other types of fittings and wire and all that. But the idea here is you would set the size and type of conduit you use the most. And I think these settings are pretty good, pretty typical for commercial electrical contractors. If you were doing more industrial, maybe you would change the default to GRC or PVC coated GRC or something else on this list. But again, for commercial, these probably work well. You might look at the fittings down here. We've set it to set screw steel fittings. If you use compression steel more often again, you can set that down at the bottom under the terminations and under the type of coupling here. So that's the idea here with the default settings, is you can set them to your preferences. And again, if you're doing commercial work, I'd probably leave them pretty much like they are, but you can even set the type of support default. Okay. So let's actually create a little job so we can look at some of the things that come into play when you actually set up and take off a feeder. So I'm going to set up a new job, and we'll just call this feeder webinar. Try to type that in. And I don't think anything else is important on this screen as far as the webinar here today, so I'm just going to hit OK. And we're going to go to wire and conduit takeoff. Now, the branch circuits, the feeders, and the site module screens all look pretty similar. The differences are kind of subtle. I always tell people, if you learn the branch circuit takeoff really well, you know about 90% of what you need to for feeders. And I'm going to explain a little bit later why you might want to separate your entries into feeders. I like to put anything inside the building in the feeder takeoff, anything outside the building in the site takeoff. That way you've got it automatically separated when you go to your reports, or there's a report that'll separate them automatically. Okay, so let's just set up a typical feeder. It's going to go to panel P1. This from to and the designation are not required, but I strongly recommend that you put them in, because that way, again, when you look at your audit trail, it'll be clear what you were taking off, and when you run your reports, it'll be clear what you're taking off. So I'm going to go from the main switchboard to panel P1. And I'm going to leave it on 2-inch EMT. I'm going to go to 4/4-aughts. I'm doing this for a particular reason. In case you haven't seen this, I'm pretty sure you would have. And I'm just going to put in 150 feet. And I'm going to put in one run. I'm going to put in 3 elbows. So one of the first things you want to think about with feeders is the difficulty. Things like ceiling height are important. You might even want to go to difficult if it's a short run. If you've got a 10-foot run of conduit to a panel that's, on the same wall, the labor that you use for a short run like that might be more than you would normally use. Now, we'll talk about parallel later, but basically the choices here are standard and difficult. If you have the Pro version, you can put a factor down here, and that can be plus or minus. What up here does is changing from standard to difficult, it adds 50% to whatever labor column you're on. So if you're on column 2, which is the default for most people, and the labor unit is 4 hours per 100, if you go to difficult, it's going to be 6 hours per 100. It doesn't change anything else in the screen. This one down here, which is again is a feature just of the Pro version, that would factor everything on the screen. So if I put 20% here, my fittings are going to get 20% extra labor, my wire, my conduit, everything. So I'm going to keep this pretty much to the plus features, but I'm going to go ahead and hit takeoff here. I just want you to see, if you haven't seen this before, that it checks the wire fill here. So if I hit return to correct, it doesn't like me trying to put 4/4 and a number 4 in 2-inch EMT. I can bump it up to 2.5 inch and hit takeoff. So those are the two options to factor labor. Makeup here for feeders is the total for both ends. So if you want 5 feet at each end, you put 10 here and you hit OK. I think that was it mainly for feeders. Okay, so let me show you how to take off a parallel feeder. Actually, I'll do it in the site module. So let's say I've got a feeder going from the transformer to the main switchboard. So the designation I might use is MSB. On the from to, we're going from the transformer to the main switchboard. Okay, so here I'm going to have, let's say I've got 3 conduits. I'm going to make them 4-inch conduit. And if one of those conduits or one or more is empty, you would put that here. Now, it knows that any of the empty conduits should get pull wire, and the rest of the conduits will get whatever you put in here. If you want to look at that setting, I see a couple questions already. I'll pause in just a minute. So down here is the default on the pull line for the empty conduit. Again, it does that automatically. So I'm going to put in 4 500s here. And I'm going to put a length of 80 feet. That's the distance from the switchboard. I'm sorry, from the transformer to the switchboard. Because it doesn't matter whether you're going from A to B or B to A. Now, because I put in 3 conduits here, it's going to multiply that and give me 240 feet of pipe. It's still one run. A run is from starting point to ending point. If I had a pull box in the middle of that feeder, that whether it was in the site or in the building, each that would have an additional run. I'll talk about that when we go to parallel in a minute. So number of elbows is per conduit. So I might change that to 2, and then for the type of elbow, if I'm running underground, probably want to use the long radius elbows. Now again, underground, we don't need a support unless you want to use the base spacers or the intermediate spacers, which are available down here. But let's assume we're just going to put that conduit in the trench. And for the termination here, we might want to go to bell ends. So if we're stubbing up into a transformer pad at one end, stubbing up into a switchboard at the other end, this is probably a good selection. Now the couplings might sound a little bit confusing here. PVC comes with a coupling. So the coupling is only for the purpose of picking up additional couplings for the elbows here. So because I have 2 elbows, I'm going to get 2 extra couplings. There is a setting for that. If you want more than that, you can change it. Now, again, I'll get to the questions in just a second here. So I'm going to put this feeder underground in a trench. Now, when I go to the trench tab, I need a minimum of 2 selections here. I need to dig the ditch, and I need to backfill and compact it. Now, for trenching and excavation, probably would want to use a backhoe here. And then maybe we'll use 24 by 36, 48, 60 inches, whatever the requirements are. 48 is usually a pretty good depth. And it automatically fills in the length. So for the backfill and compaction, you got to hit this little back button twice. Go to backfill and compaction. Now this one I'm going to actually only backfill 36 inches because I'm going to put a foot of concrete in that trench. So that's 80 feet, 80 lineal feet. And then for the concrete, that's under concrete, sand, and backfill. We'll go to concrete, and we'll do 3,000 pound. So the length is the same, 80 feet. The width, I'm going to make it 2 feet wide and 1 foot deep. And then it calculates that out to almost 6 cubic yards of concrete. So the other thing we might want to put in here is some tracer tape, and it automatically puts that length in too. So with trenching, again, you need to backhoe or dig the ditch, you need to backfill and compact it. If you're going to put anything other than native backfill in, we need to calculate that. And then the tracer tape would be here. Oh, almost forgot, good. Now, the difficulty here would actually be 3 parallel. Because I'm running 3 conduits, one of them's empty, but because we're running those 3 conduits simultaneously, we want to figure in some labor savings for doing that all at the same time. So that's a real important part of thinking about with feeders. I wouldn't do it in 2 other situations, but we'll talk about that in a minute. The parallel factor here, when you go to 2 parallel, it gives you 20% labor, 20% less labor. So again, if the labor unit was normally 5 hours per 100, it would knock it down to 4. If you go to 3 hours to 3 parallel, it knocks it down to 40% to 3 hours per 100. So the parallel factors are 20, 40, and 60, and then it stops there. Okay, so that's a pretty important factor. Now, I'm going to put in 10 feet of makeup. That gives me 5 feet at each end, and we'll hit OK here. Okay, so let me pause this, see if we got some questions. I see somebody's got a raised hand. Additional types of fittings here. If you've got them in the database, then you go into the attributes and to tell it where to pop that up in the program. Let me see if anybody else has a raised hand.
Brian, did you get the question on the setup screen? You mentioned something that was available only in the Pro version in the questions
Yeah, that
panel?
wasn't the setup screen. That was
Okay.
on the takeoff screen. This labor factor and material factor, those are only on the Pro version.
Okay, and then there's one more question. If you're taking off length.
If you're taking off a length in PlanSwift, how do you do the concrete after the measurement before pushing F2? So you have to manually type it in when you go to the select items and you go to concrete. So you would have to pick one of these, and then you have to manually fill in the length and you really wouldn't ever use the PlanSwift button over here because you can't measure cubic yards. You just have to manually put in the length, the same length you put up here on the overall length, and then you have to tell it what the width and the depth are. Yeah, so that's a manual thing. The PlanSwift isn't going to help you with that. Let me see if there was another question there. Yeah, PlanSwift won't put anything into this field here for the length on the backfill. It doesn't fill that field. You have to manually type it in. But again, it's going to be the same number you've already measured up here, whether you've done it manually or whether you've measured it with PlanSwift. You're just going to take this same number from the overall length and type it into the length field here. So I'm not sure I'm totally answering the question, but I'm trying. Okay, so we talked about parallel multiple conduits. Let's talk about a feeder with a trapeze hanger. If you've never done that, we're going to do, and I'm going to do this in the feeder module. So let's say I got a feeder to panel P2. The from to is from MSB to panel P2. So we're going to go to 2 conduits here. I'll leave the conduit size, leave it on EMT. Now, on the difficulty factor here, again, I would normally go to 2 parallel. The 2 exceptions to that would be if it was a very short run, 5, 10, 15, even 20 feet, I'd still leave it on standard. And more importantly, if it's a change order, I definitely don't want to use the parallel factoring because I'm not trying to lower my labor units, my labor hours on a change order. I'm trying to justify as much as possible. But we'll assume this is just a regular bid. So on the overall length here, I'm going to put in 160 feet. Now, again, by definition, that's one run, unless I've got, let's say, a pull box in the middle of that run, or somewhere in the from the starting point to the ending point. So I'm going to put 2 runs here. Now, elbows are per conduit. I've got 2 conduits, so if I put in 3 elbows, I'm going to get 6. Now, to put this on a trapeze hanger, you first need to select the unistrut strap as the support on this page here. So because I've got 2 conduits, it's going to give me 2 unistrut straps every 8 feet. The trapeze hangers have their own little tab. So when you go to select items here, I don't know if you've noticed, but we've got a whole bunch of stainless steel pipe and fittings, including stainless steel trapeze hangers. Can't imagine how expensive those are. But anyways, I'm going to go to trapeze hanger suspended from a steel beam. We'll go to 2 foot wide with 4 foot rods. And it automatically assumes you're going to get one of those every 8 feet, which would be typical. Okay, so now when I hit takeoff, I'm still going to put in the 10 feet of makeup. Again, that's per run, per wire, total for both ends. And there you can see down here on the bottom of the audit trail, I got 20 trapeze hanger assemblies because we took off 160 feet. It gives us one of those every 8 feet. And then it puts all the parts into that trapeze hanger assembly down here, plus the unistrut strap right above it. And then the typical wire conduit. So you'll see that labor unit on the 2.5 inch EMT is 3.6. That's 20% lower than whatever the normal 2.5 inch EMT would be. Another thing that comes up quite a bit is if you have a feeder with multiple types of conduit. And that could happen in a couple situations. You might have a feeder that goes under the slab and gets to some point where you need to go up to another floor with a different type of conduit. Could be a feeder coming into the building, and then the services may be up on another floor or another location. You got to run conduit to a second location, a second type of feeder. Now that requires 2 entries. Okay, so same thing would happen if you're doing a site feeder where you've got 2 4-inch conduits and 2 2-inch conduits. You got to make 2 entries. And one really important thing to keep in mind is you want to give each of those its own designation. So we're going to make this P3-PVC. I can even just abbreviate it P. So the from to is, let's say it's going to be from the, let's say the transformer again. Let's say we got a pull box, let's do that. To panel P3. And it's just going to be 1 conduit. And I'm going to take it off in PVC. I'm going to leave that same 4/4 aughts. That's fine for what we're doing here. Let's say that's a 100-foot run. It's 1 run. I want 2 elbows. They can be PVC or rigid elbows. Typically, I don't need the support. I might want to do trenching. I can kind of cheat a little bit here. I can hit recall last. Oh, I did that in the site module. So if I want trenching, I'd go to trenching. I'd go to backhoe, and let's go ditch witch on this. We'll go 6x24, and then we'll do backfill and compaction. We'll do 6x24, and that'll be it for this feeder. Now, I'm going to take this off. I'm going to put in my makeup wire, and then I'm going to run another 20 feet up to the 2nd floor to a panel. So I'm going to call this P3, panel P3. I'm going to do that in EMT. This is from the, let's just say from the ground to panel P3. Now, you don't want to use the same designation for both feeders, because if I labeled this the same thing I did the previous feeder, it would change everything there. Same thing happens in fixtures, by the way. You don't want to do that. You want to give it a different designation. So we got 2.5 inch, we're going to go to EMT. And then we might want to put a support in. Maybe we'll do unistrut straps or something with unistrut. We'll put in, we've already got elbows here, so we don't really need any more elbows. And let's say that's a 20-foot run up to the second floor. And I don't need any more makeup wire. I've already got the makeup wire from the first entry. Okay. Now you'll notice I took off some feeders in the feeder module and some in the site module. The nice thing about doing it that way is that, let's get rid of that screen there. There we go. When I run this report module up here in the top right, it's going to give me the feeders just for the feeder module. I think I've got 3 entries here now. I got P1, P2, then I've got 2 entries for P3. So if I go to the site module and do the same report, it's just going to give me the 1 feeder I took off underground. So it's just a really easy way to automatically separate your feeders, because typically you're going to do those in different phases of the job anyway. And if you could use the sections and breakdowns, there's no problem with that, but then you've got to create a section for the site work, a correct section for the inside feeders. And if you really don't need that for any other reason, in the sections up here, you can just use the report from each module to keep it separated. Those are really handy reports, for just verifying conduit lengths, wire lengths, things like that before you order material or cut wire. Okay, let's see if there's another question. I see a raised hand here. I'm looking at my taskbar.
Brian, there was a question here, if you can get to it, I'm not sure, but there was a question from Matt Ide regarding adding fittings to the module drop-down list. He missed your response. Could you
Okay.
review where to find the process required?
Okay, I get my question window to pop up properly. So the question about adding fittings to the drop-down modules was, the materials that you want in those drop-down modules have to be somewhere in the database. So if you don't know where they are, you have to find them or you have to add them to the database. The second one, which is the tough one, is you have to use the attributes feature to assign it, and that's a whole nother topic. It kind of gets, it is pretty difficult the first or second time you do it, but there is a place in the setup in the database that you can assign attributes. What the attributes do is tell the program what you want to pop up in any of these drop-down menus. So whether you wanted to add more wire types, more elbow types, more support types, there are attributes in the database that tell it what to appear there. It can also be used in reverse. If you don't want things in that list, you don't have to delete them from the database. You can actually just delete the attributes so it doesn't pop up in that part of the program. I think I did see another raised hand here. I'll come back. We're almost ready to wrap up here, so I'll come back and check the questions one more time. So here's the last, it's a kind of a minor topic, but I know it's something that you don't always think about. I'm certain I've missed it more than once. Let's say you're running a conduit from an existing switchboard to an existing panel board. So we'll call this P4. From MSB to P4. But again, they're existing. So the program normally picks up the labor for the wire terminations with whatever you put into the switchboard, circuit breakers, fusible switches. Even if it's main lugs only, it's going to have labor to terminate the wires of the switchboard. Same thing in the panel board. If you put 42 20 amp breakers into a panel board, it's going to have labor for terminating the wire there. But again, if it's existing, then it's not going to have that labor factor. So let's say I've got 100 feet going from the switchboard to panel P4, put in some elbows. We'll change the support here. I like this one here, the 2.5 inch conduit hanger with threaded rod from a steel beam right there. Gives you enough material and labor to cover a lot of various situations. But when you go to other items here, there's a category in the database that has wire terminations. If you don't know where it is, you could search, or I can just tell you it's under distribution equipment. motor control, and wire terminations. And then it's down here, motor control and wire terminations, and then we can do wire termination labor. So let's say we've got 4/4 at both ends. I would put in 8 wire terminations here, and that would give me labor to terminate the wire into the circuit breakers in the switchboard and into the panel board.
Okay, I would like to go ahead and thank everyone again for joining us today. And I guess this goes ahead and concludes the webinar today. I hope everyone has a wonderful rest of your day, and give us a call or email if you have any questions. Thank you so much.